Shashank, I hope we can start.
నువ్వే ఆలోచించు కొంచెం అమౌంట్ చేద్దాం.
Uh, shall I start? It's only 7, no?
Okay, or else we'll wait for 5 minutes, okay?
Okay, only 15 participants are there. That's what
Okay.
I'm observing also. Only 15 are
Yeah,
there.
yeah, okay. Okay then. We'll wait for 5 minutes, okay? We'll start at 7:05.
Sure, sure, sure.
Yeah, thank you. Shashank, hope we can start now.
Yeah, we can start.
Yeah, thank you.
Fine. So good evening, everyone. So welcome to the day 7. And let us continue with the concepts, right? So yesterday we have discussed about random forest, right? So decision tree and random forest we have done. So what we are going to do is today we let us discuss about the interview questions in the point of view of decision trees and random forest. Okay, because those are the two one of the biggest concepts, particularly random forest, right? So let us discuss some of the questions and how questions can be asked and what are the potential and possible questions that can be asked. So we'll discuss in detail. Okay, so around 35 questions I have picked, right? So we'll try to discuss as much as possible in this session. So let me share my screen. I hope you can see my screen. Yeah. Okay. Fine. So let us go with the from the basic questions to the advanced level. Okay. So I framed some of the questions which I have taken from the internet as well, and from multiple sources. So these are some of the basic questions what I majorly observed, in interviews which being asked. These are the 10 basic questions, and then we have 10 intermediate questions as well, which can be actually, which have the potential questions to be asked. And then we'll have a little bit advanced questions as well. And then after that, we'll go to some practical scenarios, how, where the decision tree and random forest can be implemented more. Okay, so I've divided into 4 different parts. Practical is what the 4th level, and then the advanced questions, the level 3, and then we have the intermediate questions, and then we'll go with the basic questions. Okay, so we'll discuss each in detail and understand how things work out when it comes to decision trees and random forest. So now let us start with the first question. So what is a decision tree and how does it work? So as I told you, these 10 are the basic questions, right? So the questions also will be really related to how you keep it very simple. So just to understand that whether you know random forest or you know decision trees, what happens in decision trees? Okay. Here, if you can see, first 8 questions are based on decision trees and 9 and 10 are based on random forest. So I think you would have guessed by now. Why? Because most of the concepts what are there in decision trees are also implemented in random forest, because both are actually, you know, almost similar. Little, two models we are mixing, right? That is bagging, and one more thing is multiple decision trees. That is what we are mixing into to form a random forest, right? So yesterday we have discussed in detail. I hope you remember. So that is why this concept of Gini impurity, entropy, information gain, right, and mean square error, right? All these things, pre-pruning, post-pruning, right? Root nodes, all these things, concepts are basically also a part of random forest. Okay, so that is also coming into, so it's like a mixed bag. So that is the reason I have together taken for decision trees and random forest. So this is where you have to keep it in mind as well. So what is decision tree and how does it work? So to answer this question, right, the simple way to answer this question is basically you can just tell that a decision tree is a algorithm, right, based on a tree structure. Okay, and or I can say decision tree is actually machine learning, or if you want even more to say, like you can say decision tree is basically a supervised, right, supervised machine learning algorithm which is helped or which is used for decision making, right? Yeah, which is used for decision making. And the decision is taken, and the formation of a decision tree is in the form of a tree structure, right? And this is one of the few algorithms where classification and regression both are possible. Okay, so like how a certain algorithms are there, only a few algorithms are there which are possible of both classification and regression. So that is one of the algorithms is decision tree. So that is one thing you can just to start out, you can just tell this. Okay, so after that, once we start with this sentence, okay, you can also tell that there is also something called as a a root node, the leaf node, the branches, everything. You can just have a quick overview, right? So based on the situation, you can just answer that, keep it very brief. Okay, because that is something where, for example, if you are giving an online interview, maybe you can just draw it and show. But if you're giving an offline, you cannot draw it in the sky or something like that. So you can just tell that there are something called as a root node, branch node, and leaf nodes. So these are some of the components. Actually, our second question is that only. So there are some of the components which a decision tree actually has. You can just very on an outer picture, you can just tell that. Okay. And now going to the next part, because you just have to keep it very simple. How much of decision tree, or how much you want to tell for decision tree. Why? Because there is one more question which is attached to it. So we are saying what is decision tree and how does it work, right? So we also have to mention that how does this decision tree actually work. So that perspective also we should answer the question, right? So we should not skip on one part and answer only the other part. So we should never do that. So you can keep this in mind when you are answering the questions. So you have to keep it very simple and make the person understand in a very layman language that what is a decision tree, and then you can talk about how does it work. So when we talk about how does it work, the simple way to keep it or to tell is, you can say that decision tree is an algorithm which has splitting. Okay, because that's what happens in a decision tree, right? So you have seen the decision tree as well in the earlier ppts. So it has a sorry, it is an algorithm which works on a splitting, and you can tell that the splitting actually occurs based on some parameters, or you can say some criterias. Yeah, you can say this. The splitting happens on based on some criterias. So what are the criterias is entropy, right? Entropy and okay, so you can say entropy and information gain for classification, okay, and Gini index particularly for the regression problems. Okay, so actually Gini index is also used for classification, but usually Gini index will take it for regression part. And then we can say that based on the impurity, right? Because basically the concepts of actually you don't need to speak that much, because again we have a question which is when we say you can see the fifth question. So what are the criteria used for splitting in decision trees? So again, there you have Gini impurity, entropy, information gain. Again, anyway, we'll speak about that. But since they asked this question, okay, so actually it covers a few things as well. What we are doing in the other questions also. Because when somebody asks you how does it work, okay, so please tell me how the decision tree works. Actually, he is asking a big question. To be fair, okay. So since it is just an explanation of the concept on the outer picture. Correct, no? So since it is an explanation of a concept on the outer picture, we are not practically doing anything, right? We are not showing any PPT, or we are not telling any, any pictures or something like that. We are not showing anything and telling that. So that is why it becomes a basic question. It becomes a basic question. We are not explaining using something, a board or something like that. We are not doing anything. So that way it becomes a basic question. So vaguely, you can just tell how does it work. So the person kind of asked these questions to make sure that at least if a person who doesn't know anything, if they ask you something like this, can you answer this question? So they try to understand your explaining ability, and how much you can keep it very simple also. So in that sense, you can tell it is an algorithm which is based on splitting. Okay, very simple. We'll try to work it out. So we'll tell that it's an algorithm which is based on splitting, and for splitting there are criterias. Okay, so like Gini impurity, like Gini index, entropy, information gain, there are some criterias for splitting. Okay, so on that splitting, the important features are selected, based upon the certainty and uncertainty in the data. Don't even talk about the word impurity also. Again, you have to justify what is that. Okay, let me. So I can just say based on some certainty and uncertainty. Okay, because basically the amount of uncertainty is what is impurity actually. To be to be precise, because what you are saying is uncertainty itself. The amount of uncertainty is what impurity basically in the data is about. So rather than we can tell that, right? So it is basically an algorithm which is based on splitting, and it is something where it relies on that uncertainty to split the features. What are the important features and all? So based on that, we have the we have the splitting part, right? We have the splitting part. We have a root node, right? We have the leaves, branches, and all those things. And there's a criteria also when to stop and when not. The splitting part, when to stop and when not to stop, so that it doesn't overfit. Okay. And one more important thing is just give me a minute. One more important thing is one more important thing is the main issue in decision tree is basically overfitting of the data. So that isn't where what we try to do is we try to analyze in certain way. We try to analyze in such a way that it doesn't overfit. Okay, and that is what we have to do when it comes to the when it comes to the splitting of the algorithm. So in that brief note, you can tell and you can close out the question. Okay, because we cannot, as I told you, right? So if they ask you to implement and show, that's a different criteria. But just vaguely, if they're asking that how does it work, just tell me a brief outlet. So you can tell this much only. Yeah. So based on this criteria and all, it gets splitted, and you should be able to figure it out when to stop. Because if you if you keep on making the tree complex, so the problem of pruning might occur. So pruning is nothing but the growing of unnecessary branches. So that much I think it should be sufficient. Okay, so maybe if you want one or two advantages and disadvantages, you can tell. Okay, that is completely based upon the person. Because after listening to a few points, some people might in my experience, I'm telling you. So some people will say, okay, fine, I got it, right, let us go to the next question. So like that, they might say. Okay, so if they're patiently listening, you can tell, because anyway you would have prepared and went, right? And so you can tell whatever right? And always remember one thing, I'm telling you with very this is a very important thing. Never try to beat around the bush when you are actually answering a question. If you know the question, the correct answer, just tell the answer. If you're not knowing, just can say, I'm not sure. Maybe I knew it, but I couldn't remember or something like that. So just tell that particular thing. Even in the middle of the things what you are asked, answering also, there also, if you're not able to answer a certain, again, they might ask you, for example, suddenly they might ask you what is an entropy, right? You might remember or you might not remember. Okay, because not everybody remembers everything at every moment. That is not possible. So if he asks, for example, if you can remember, just answer the question. If you're not able to answer, just keep it very simple, stating that I couldn't remember, or not able to remember, that kind of right now. So anyway, basic things and all, nobody will forget, because we prepare for the interviews and go, basically, right now. So we don't vaguely go, right? Just for fun, we never go for an interview. Okay, so so the preparation will automatically there. So I think you will be able to answer the questions, unless and until you really don't know, you can just tell that. So coming to the next question, what are the key components of a decision tree? Okay, so root node, decision node, and leaf node. Sorry. So for this question, you can just explain what does a root node do. Okay. What does a decision node does, and what does a leaf node actually does. So root node is at the top, right? We already have discussed on this, correct? No. So basically, this root node, where we can actually just wait a minute. Okay. So basically, the topmost node is basically the root node, right? So where the point where the decisions, or you can say the splitting part actually begins, right? Where the splitting part actually begins. So from there, we have a decision node where decisions are taken after the splitting part, and then the leaf nodes are basically the terminal nodes where there is no splitting possible, right? Um, yeah, where there is no splitting possible. And there is one more criteria here, which are called as the branches. So branches are nothing but the connection. These are nothing but the connection between the nodes, right? So basically the connection between the nodes, you can call it as a branches. Okay. So let us go to the next question. What is the difference between classification and regression trees, right? So he's particularly asking what is the difference between, no, he's not asking about what is classification and regression. He is telling what is the difference between classification and regression trees. So he is asking in the point of view of trees. That is, either it might be a decision tree or a random forest, because these are the tree-based structures. So you have to answer the question based on the kind of answering on the based on tree criteria. Now, how to answer this? Basically, we have to identify that you know uh, usually what we are going, why we are using this algorithms basically to I can say predict a target variable, correct? No, so that is one thing you can just tell. And after that, when it comes to a target variable, in target variable there are two kinds of variables, correct? No, that also you already know. So one is classification and one is regression. So something which is a categorical variable, such as yes or no, true or a false, right? Yeah, you can take it as a categorical variable. And something which is a continuous, you can tell that it is a regression. So in this plane, when it comes to the splitting criteria also, as we already have discussed, for classification, we use the entropy, right? And the information gain particularly. Okay. And we can also use the Gini index, right? And when it comes to regression, we basically go with the methods of mean square error. So we already know that for regression, we are going to use the mean square error and mean absolute error. Root mean square error also we are going to use. And coming to the next part, which is the leaf outputs. For leaf outputs also, they are basically determined on the majority class. So whatever majority it's going to take inside, okay, is going to give that. For regression also, it's going to build, right? It is going to take a particular numerical value. What is the predicted value based on the model building, and it's going to predict. So that is how you can and for this, any example if you want to give, you can give some. We have done the house price prediction, right? So we have done the house price prediction. Uh, I think house price prediction, we have done only one for continuous variable, correct? And then you can say that estimating the temperatures, right? And predicting the sales of the next quarter or a next month or a next week of a company, right? So you can understand, how much of how much of money has to be spent on a marketing ad or something like that. So all these are regression examples. So for classification, you can tell we have done. You can tell our examples only, right? We'll be doing some more, and you can tell whatever we have done till now also. So like attrition, right? So for HR attrition rate for logistic regression we have done. So you can say by predicting the attrition, we can we can identify whether the employees will stay in the organization or not. That is one example. Even email spam detection, you can tell. then we have done one project, right? So identifying the fraud, right? So fraud in transactions. So identifying the fraud in the transactional data. So, yeah, you can give some examples, whatever you know, which are very much related to a practical day-to-day examples. Okay, so very much in trend, something like that. So email spam detection is it's an old and a trendy concept. Why? Because the spam detection thing goes on and on and on, because we are using the email on a day-to-day basis. For example, the training will be done on a day-to-day basis, because the different kinds of emails are produced, right? So the model has to train. So if a certain model is not able to deliver, again we have to work on the model building and all, right? Because data keeps on coming, and training keeps on happening on the real-time environment. So next is what is the concept of splitting in a decision tree, right? So basically, what is splitting? Splitting is nothing but if you tell what is splitting exactly, what is the concept of splitting in a decision tree? You can say the concept of splitting is basically the dividing the data into smaller subsets. That is what splitting is. Correct? No. So on what basis it is splitted? It is splitted on the basis of certain features or parameters. So, this splitting actually helps us to, take a decision, right? Because, in a tree structure, splitting only doesn't mean that it is actually forming a tree. Splitting also tells you that how much that particular feature is important, right? Right? When building a tree, right? So what is that tree exactly? The tree is helping you to take a decision on a parameter. So if you choose this path, what are the outcomes you can get? If you choose a certain path, right? What is the parameters? Sorry, if you choose a certain path, what are the decisions you can take? Or if you choose one more path, what are the decisions you can take? So it's not just a tree. It's a decision-making house, right? Where you are actually taking a decision, right? And on that, you are going to move forward. Okay, so it is very important. So splitting plays a very important role when in a algorithm like decision tree or a random forest. So it is very important that the splitting is done on a very important feature or an important features. Based on that, we can form a tree and go with the decision making. So you can keep it very simple and explain in a certain way. So how can so in that again depth, if somebody asks you, you can tell about the key aspects like how does a classification get split, regression get split. So that is up to you if you want to detail. So anyway, I've covered the concepts. You can just tell on the maybe with an example. You can take one example, and how does splitting happens in the real time. So that you can just explain with a very brief example. Okay. So done, that part is done. So next question, what are the criteria used for splitting in decision trees? So yeah, I'll take some questions after this fifth one is done. Okay. So if you have any questions, you can ask me. After the fifth question, I'll take up the questions. So what are the criteria used for splitting in decision trees? And Gini impurity, entropy, information gain, mean square error for regression. Okay, so you already know, right, what what these things do, correct? No, so that you already know what is going to happen, right? So what you have to do is, if somebody asks this question, the very simple thing is you can just explain if they ask you formulas, okay? And I already told you about this formula business. So those who are, I told you, those who are more into math and stat, they love this, things. They try to push asking you what are the formulas and all. If you remember, you can tell, okay, or else you can just say that, I'm aware of the concept, but not exactly the formula. So that is, based on the person who is asking. So some people push. I've seen people pushing on the formula part. See, here, the truth is what I'm trying to tell you is, formulas you need not remember on a certain aspect. Okay. So obviously, when you learn the concept, right? This is how the functioning. See, that is the reason we explain the concept as well before doing the implementation part in Python. Even at least I don't teach like that, where I just directly jump into the practical part. So I never do that. Okay. Just we have to understand how it works, right? So when you try to understand how it works, obviously you'll be able to figure it out that these are the formulas. Okay, this is how it is working. So you need not by heart those. So when you try to see, okay, this is how it works, the functioning and all, obviously you will remember it. Correct. No. So now that actually comes through practice. So multiple times, if you prepare for the concepts and read the concepts and understand the concepts, obviously you will remember the formulas automatically. That will be remembered in your mind. Okay. So except some very very huge formulas, what you see in deep learning. Okay. So in deep learning, you see some ridiculously big formulas, mathematical formula. So I mean, I find it very difficult. I'm very good at deep learning, but still, I find it very, very difficult for some formulas to remember. Some I remember, some I don't. So it happens. Okay. So nobody is perfect and nobody can remember everything. So it is very important for us to, when we practice, we start understanding the things. So on a, small note, obviously you'll try to remember. So if you try to, if you remember it, just answer it. Okay. So and very few people will be there who will ask me the formula. I'm telling you, but the percentage is less. But there is a amount of probability is there that they might ask also. So for Gini index, you already know the formula, right? So 1 minus summation pi square you can take. So next for the entropy part. So for entropy part, we have the formula minus summation pi into log pi, right? So we have seen no minus p into p1 into log p1 and minus p2 into log p2. So you have seen the formula. So basically that is two I can say two outcomes are there. That's why we have put two. So basically what is the formula is minus summation pi, right? So you can just go back to our PPT also I've shared and all. So there you can see. So minus summation pi, so log pi's, right? So when you take that, obviously you will get the entropy where it is using the probability as well as the logarithm. So for information gain again, so we are going to use the entropy of the parent minus the a formula where you put summation, I can say dk divided by mod of dk divided by d. Okay, so it is a subset of the split and the proportion of the split into your entropy. Okay, so anyway we have done the information gain, so it will be easy for you to even by looking when what we have done, you may remember the formula when it goes, when you move little forward. Correct, no? Now let us go to the next one, which is the Gini ratio. So for Gini ratio, this is basically there is a formula for Gini ratio, which is information gained by the split information. Okay, and then for the mean square error, you already know 1 by n summation. You can take yi minus y bar whole square. So this is basically observed minus your expected value. The difference between observed and expected value, squaring the term, dividing it by n. So that is what your mean square error basically is. So reduction in variance is usually the variance formula. Okay, so you can apply that using that variance formula. Okay. Yes. So let me take some questions if somebody has any. Okay. Let me check. Uh, we can just mention. I'll give 2 more minutes. If you don't have anything, we can uh, continue. Question 3. Okay, so question 3 is nothing but classification and regression. But for question 3, it is basically what you have to tell is we have to speak what is classification and regression only, but we have to bring in the tree aspect. So we have to tell what does happen in a tree. That's it only. So how does things happen in classification and how does things happen in regression in a tree perspective? Yeah. And one more question I'm saying, what is the difference between Guinea impurity and entropy? I've already explained this. So basically, when you go to the, just give me a minute. See, when, to clearly tell you Guinea impurity and entropy, okay. How do I tell you? I'll keep it very simple. Okay. Anyway, I've explained the part already, but let me tell you the in a simple way. Okay. So, what is exactly entropy is? Entropy is basically the uncertainty in the data, or you can say in a very simple term, it is the technical term what we are using is impurity. Okay. So we are using the word impurity. So what is impurity is saying is we are saying that it is an amount of uncertainty or the level of the disorderness or uncertainty in the data set is what we are calling it as entropy. Correct now? So I think you have understood this, right? Now, what is Guinea impurity is it is an index. Okay, it is basically, or I can say, it is an index. You can remember in a simple way. So it is an index which helps you to calculate, right, the probability. It is an index. Yeah, it is an index which helps you to calculate the probability, right, of misclassifying a data point. Okay, so that is why the formula basically is 1 minus summation pi square. Okay, so I'll share the answers also for the questions actually. I'm preparing that. I'll share that also with you. Okay, so it will help you also to just revise the concepts as well. It will help you on that. So I'll share that. So what is the situation here is basically the Guinea impurity should be very less because it is the probability of where it is misclassifying. So now if you are saying it is misclassifying, right, that means if the data point is something else, if it's an apple, it is classifying as a guava or a strawberry. So the classification is being getting wrong. So now what happens is it is very difficult for identifying the misprobability should be very less. Okay, so that is why we say that the Guinea index, or you can say we actually call it as Guinea index. Okay, or you can say Guinea impurity also. Why I don't say impurity basically is usually I don't say Guinea impurity, but since I've mentioned here as impurity, I guess, yeah. So since I've mentioned it as impurity, I'm saying it as impurity. But what I call is to simplify, when I'm teaching as well, to simplify things, I call it as Gini index. So Gini index, in my opinion, is something where the lower Gini index will help you for a better split. That means you can identify that the data points are not related to, the features are not related to each other, okay, much. And the classification is easy to, or I can say the splitting is easy to do. Okay, the classifying of the features, whatever is the important feature, so it is easy to do. So they're basically in what situation might be preferred over the other? We don't prefer one over the other. Actually, that question itself is not that correct. Sorry, if I told you that, it is basically uh, I can say it's basically a matrix. Okay, it is not something where there are two different formulas. It is a metric to measure how good how good our splitting actually is happening. So it is basically a metric. So usually we go with the entropy part, and then we also calculate the Gini impurity or Gini index, what I call it as. So to identify how good our actually split is, how much of less uncertainty is there in our split. Okay, because we should never have uncertainty when we are splitting. So we should confidently, I can say we should confidently split, uh, the features, what are the important features, on what basis we are going to split the tree, and which are the important features. So that 2-3 features or 4-5 features, whatever is important, we have to identify. That is very important. Then only we can take a decision, because if you're having only very less variables, it is easy to do. But if you're having a lot of variables, or the features in the data, it's very difficult to identify. That is why this concept of entropy and Gini index is used, or impurity. Still, if the entropy or Gini index or impurity is not helping you that much to split, then we go with the information gain. So that also I've explained it yesterday I think a day before yesterday. Yeah. So when explaining about decision trees. So in random forest also I've covered a bit of because the same thing applies, because basically random forest is decision tree only. So just adding the bagging concept. That's it. It's tree, decision tree only, plus bagging. So bootstrap aggregation, we say. Bootstrap aggregation. So bootstrap aggregation or bagging. So bagging plus decision tree is what random forest is. That's it. So anything else? Any other questions? Let me check. Think that's it. I think I can move forward. Sorry. So let me just go down. Next, let us see what is overfitting. Okay, the sixth question. So what is overfitting in decision trees and how it can be solved? The problem is in decision trees. To be fair, let me be very open if I have to answer this question. The overfitting problem, very difficult to solve in decision trees, first of all. That is why we are not using decision trees. If the decision tree, I would say, not decision trees. That is why we don't use decision tree when there's a problem of overfitting. Okay, so we go with the concept of random forest, where we use decision trees, a number of decision trees, right, to solve this problem. Okay, so that is what the practical aspect is, or the logical thing. But if you have to talk on the concept, okay, you cannot directly say, the person who is asking that, you cannot solve the problem, so don't ask me this question. We cannot tell like that, right? So, because I've seen this question, maybe, maybe people just want to test your knowledge on what happens inside decision tree and what happens, how this is rectified by random forest. Or this person does this person know ensemble techniques, right? How random forest works, that, there's a concept called bagging along with decision trees. Does this person know? To test this, they will ask you how this overfitting can be avoided. You can avoid at certain extent in decision trees. It's not like decision trees, you know, you know, worthless or waste algorithm, and you cannot solve this problem. It's not like that, right? It's not like that. But it's very difficult to rectify. There is this problem is, that is why when we, whenever whoever speaks about decision tree, they always speak about the problem of overfitting. So, if the data doesn't overfit, decision tree is a very good, very good algorithm. Uh, there are certain things, right? There are certain things which are implemented into the decision tree where, it tries to rectify the problem of somewhat it tries. Okay, it only tries. I'm not saying it will. That is why I'm not using the word it will. I'm saying tries to rectify some of the overfitting problem. So what are the issues basically, so what are the things it will try to do is, basically tries to do the pruning part. So we do the pruning part. So basically, in pruning, we have two types, which is pre-pruning and post-pruning. So in pre-pruning and post-pruning, what happens is, pre-pruning is nothing but early stopping. Okay, so if the tree is going too much of depth, we try to early stop. That is pre-pruning. And the other thing is post-pruning. So in post-pruning, after the branches have gone, or if the branches have grown too long or too deep, you try to remove these branches. Uh, you try to remove these branches by cutting down some of the branches, whatever you feel are not required, right? So logically, as a human being, we can think, right? So we can see that this one is not required, that is not required. So you can just remove that. So apart from this, there is one more option uh, to basically, I can say one more option basically is to set a constraint. Okay, so basically setting a constraint, um, to setting a constraint particularly on the trees, right? How much deep the tree has to grow. So if you set this constraint, so what happens is the trees doesn't overgrow. Okay, so how much of depth you want to put in the tree, how much of minimum sample splitting can be done, or maximum sampling splitting, or how many features it can take maximum. So you can put a restriction on that, and you can control somewhat the overfitting problem. So, and one more, the famous technique is the regularization. So we already know what happens in regularization. So regularization, we have the uh, L1 and L2 regularizations. And then we have the cross-validation part. So cross-validation, we have the most famous method, which is the k-fold cross-validation. Okay, and then the next thing is the randomization. Okay, which we are calling it as random forest. So to even though you have tried all these things, which to be fair, frankly, I'm telling you from my heart, if I find overfitting, I will not apply any of these things. I'll directly jump to random forest. That's it. Problem solved. Why? Because see, I'll try decision tree first if I want to use it for classification. I'm telling you, for regression, very rarely I will use. Okay. But I used. I remember once or twice I've implemented for regression in my decision trees. So I try to build. If I feel overfitting is happening, definitely I'll leave that, and then I'll go to the random forest part and try to get my answer, because I told you already, random forest gets most of the times right. So you can put your hand on your heart and you can blindly go with random forest. So that isn't where that is, see, since I have to discuss that what are the concepts which are lying inside decision trees, I'm telling you this answer, that you have methods like pre-pruning, post-pruning, So all these things I'm actually telling you. But practically, if you speak, we don't implement. If if you feel you want to, still want to fix the problem. Okay, so you can use the pruning methods, pre-pruning and post-pruning. Then you can use the setting the constraints. Then you can go with the regularization and cross validations. Then we can go with the randomization, which is basically the random forest, and the ensemble methods like the gradient boosting. Okay, so why? Because these gradient boosted trees are also very good. Okay, so gradient boosting is basically building trees with constraints. Okay, focusing on improving the errors. So this is what. So gradient boosting, ADA boosting, and all. I'll tell you. Uh, sorry, I'll tell you later. Okay, because we'll talk about boosting methods also later. Okay, so in detail we will talk, because that is again one more huge concept which we need to learn also. That's because it's a very important part of machine learning. So we need to talk about boosting methods as well, like ADA boosting, XG boosting, and all. Then we have to also speak about the neural networks, right? And that SVM. So there are some methods also still yet to we have to discuss in the coming sessions. So next is also we can do the feature engineering. Okay, and we can increase the training data. Yeah, and anyway, if none of these things doesn't work, anyway, you will forget about randomization and boosting. So that is the ensemble techniques. And anyway, what you will do is you will go with the ensemble techniques only if all these things fail. So obviously that will obviously happen automatically when you identify the problem, the problem not rectified, even though whatever you have done uh, for a decision tree. So this is how things work. So to answer this question, actually I've answered in a very huge way. Okay, don't answer this much. Just tell the just tell what are the things which you have, how you can avoid to overfit, and yeah, I do pruning. There are two kinds of pruning, like pre-pruning, post-pruning. This is what happens in pruning. What is pre-pruning? I just explained post-pruning and all. What is the cross validation? So just explain each concept in just one short lines. Prepare notes in such a way, just one line you tell it. Like that, you just answer the question for this. So just so that that you can do something in decision trees. Okay, because those who know decision trees and random forest, those who have learned, they will know that if there's a problem with decision trees, they'll go to random forest. They don't continue with decision trees. Why again we have to again don't bring the random forest, because he's asking what is decision trees. He's not saying how does it compare with random forest. So if they're asking that question, you can tell. Correct? No. So logically, if you think, right? So if I only ask the question to you, right? So I'm saying what is overfitting and decision trees, so it can be. So you should only talk about decision trees. No, you cannot talk about random forest. That is again one more algorithm. Even though they're related, right? This is one separate algorithm, that is one separate algorithm. But random forest is not a separate algorithm, it's a mixture. That's why we're calling it as ensemble techniques. But you should not speak about that, right? You can use ensemble techniques. That is a way to do in decision trees, that you can tell by telling all these pruning, cross validations, increasing the sample size or the training size, like that you can tell. Okay, to keep it very simple. Okay, so yeah, so that's why I've kept it in basic questions. These are all come under basic questions only. So next is what the advantages and disadvantages of using a decision tree. So I think this one I think we need not discuss that much, because if you just when you I can say when you implement decision trees, obviously you will understand that what are the difficulties or what are the easy things. So it is easy to implement. That is the main. That is why if something is happening like overfitting uh, in decision trees, then only we will go with the random forest. That's why. Why? Because random forest is not very easy to implement. That is the tricky part. That's the tricky part. So why you want to implement something which is very tricky if you are able to find the answer with the easy one? Logic, correct? No, that is why we don't directly try random forest. We try decision trees. If it doesn't work out, then fine. What to do? Nothing can be done. We have to go with the ensemble techniques like the random forest or boosting techniques, then we find the solution for what we are trying to do. So advantages, you can say, easy to implement. Just don't tell even any more things. Just tell easy to implement. Can handle both classification and regression. That is very important. Or you keep it that only first. Can handle classification and regression tasks. Can do both. Very few algorithms are there which can do both. In that, decision tree is one thing. So just tell that, okay. So they'll feel that you know. After this, you can say easy to implement, right? No need to scale the data. This is very important. For example, some of the algorithms does the scaling, data scaling or normalization or standardization. Decision trees doesn't need that. So that is one advantage, because again, you have to scale the data and implement decision trees, which is not required when you are implementing decision trees. Next thing is it can handle the nonlinear data. So it is not like some of the algorithms which cannot handle nonlinear data. So it is an algorithm. Sorry, it is an algorithm which can implement nonlinear data also. You need not worry if you are implementing decision trees. Only you have to worry if it is overfitting. Apart from that, you need not worry, because even nonlinear, whether the data is linear or nonlinear, decision tree itself will take care how to handle the data. That is why that kind of algorithm has been built. It will take care, right? And that is why we are calling decision trees an advanced algorithms, right? So because it knows how to implement. Okay. And next important thing is it is very it is very robust to handling the data with the missing values also. So it is it is capable of handling with the missing values, and it is very fast, and it doesn't follow any you can say it doesn't follow any statistical distribution, for example, like a normal distribution. So you need not tell that the data has to be normally distributed, correct? No, this thing we have seen for the linear regression. So but for sorry. So decision trees don't have this problem. You need not have the data to be normally distributed or does not follow any specific distribution, because it's not a parametric distribution. The decision trees algorithm itself is non-parametric. So since the decision trees is non-parametric, it is very easy because there is no assumption. So that is one thing you have to tell. This is very important part. Never, don't miss this part. Okay, it doesn't need to follow any statistical distribution because there is no parameter involved. It's a non-parametric algorithm. Okay, it will train very fast. So easy to implement anyway. We have told it is robust to missing values, and yeah, and this one also we can tell it can handle both categorical and numerical data. So anyway, you have told this, it is capable of classification and regression. So both, I think that should also suffice this. Yeah, probably this much. Yes, you can tell for this advantages. So for disadvantages, first thing you have to tell is it is prone to overfitting. Yeah, this is the biggest problem of decision tree. So never miss this point. And it is sensitive to the noise. That is why it is going to overfitting. So why overfitting happens? Because if it is capturing additional things in the data. So if it is capturing additional things, then only it is also capturing the additional noise in the data, which is not required for the model to build. So since it is capturing all these unnecessary things also, that is why it is that is why it is going for overfitting. So you can tell that it captures since it captures also noise, or you can link both. You can tell like this. So it is sensitive to, it captures the noise. Because of this, what is happening is the problem called overfitting. You can tell like this. So which will cover both together in one go, because of noise capturing only overfitting is happening. No, so you can justify by like that, and bias happens because of this problem. Okay, and then because of this, optimal splitting also doesn't happen because of this overfitting problem. Yeah, so these things you can say. Yeah, because of this, generalization doesn't happen. Uh, huh. And yes, one more very important thing I wanted to tell for this question is it also ignores the correlation between the variables. This is very important because there is no statistical element which is involved in decision trees. It is non-parametric. It is, it doesn't use any statistical things except that formula, right? That's mathematical. It's not statistical also. So except, only the probability plot it is using. So, nothing much statistical in it. So it is excluding that correlation between the data points. That is sometimes not good. So because of that, what happens is it will not be able to, generalize properly, and it's not able to perfectly capture what is the relationships exactly between the variables. So because of that, what happens? It captures the noise, and because of that, it is ultimately leading to the overfitting. So you can link what is whatever is linking up to overfitting. Okay, you can just make a round table, linking points to what links to this overfitting problem, and you can tell in that things, that key points which link to. So because of all these situations, it is overfitting also. So that is the biggest disadvantage of decision. Like that, you can close out the question. Okay, so that will make the person understand that you know things. So next is, what is pruning and decision trees? So pruning and decision trees, I think already we have discussed what is pre-pruning and post-pruning. So pre-pruning, cutting down the trees before itself, early stopping. And post-pruning is basically when the tree is fully grown, you are trying to cut down the unimportant things which after it grows. So you can just simplify the, you can just simplify what you want to tell, and you can just tell the answer for pre-pruning per. Um, okay, so actually, I've actually thought of telling you an example for pre-pruning and post-pruning. Yeah, I was thinking in that mind when I was just preparing for these questions also. So I was just thinking in my mind. So just give me a minute. This is cheap. If it's possible, you don't mind, can share attendance to my mail ID. Sir, you can send this message to Shushmita ma'am. She's the one who is taking care of the attendance part actually. Please don't mind, sir. So she's the one who's taking care of the attendance. So you can ask Shushmita ma'am. I think she's there in the meeting also. You can just share this message to her, your mail ID and all. She'll be sending you the attendance thing. Attendance thing I'm not taking care of, sir. So I can share that too. Okay, so let us continue where we are. Yeah, so just wanted to tell you one important. I was just just wanted to tell you one analogy, right? Just want to link a very simple example with students. That is what I was thinking when I was just preparing, thinking how to answer these questions and all in my mind. I just wanted to answer, um, you know, a small analogy I just wanted to tell you. So, for example, what is pre-pruning? You can tell this very simple example. Pre-pruning is basically, sorry, it is basically stopping the student from studying further because their current performance seems sufficient. That is pre-pruning. How do you explain this? Is a student, studies really well, right? So you're stopping him from, doing even more very good performance, right? That means you are saying the performance what you have given now is fine, right? Kindly do not, uh, kindly do not, give even more better performance, please stop here. Okay, please stop here. Don't give more performance. Maybe you can link it with your exams. So you already got 98%. So don't give more performance more because we are sufficient with your performance. So that is pre-pruning. Okay, stopping the model, right? Dropping the model because many students are there. So I just wanted to take this example. That's what I had it in mind. So you're telling the model that you can tell this example to link with anything as an example, and you can tell it will be really good. The person will know that what is pre-pruning and post-pruning. So you can tell that you're saying the model. Yes, it is sufficient, right? It is sufficient. The accuracy what you have given is sufficient. Please do not try to even more push to give a better performance. Okay, so the sufficient is sufficient. This performance is sufficient. That's what you're telling the model. Now, what is post-pruning is, what you're telling is, let the student study everything. Okay, and after that, right, let him study everything for the exam. Okay, and now we are saying that let us cut down what is our sorry, after he studies everything, let us cut down whatever is unnecessary, and then from the material, correct? No, whatever is unnecessary, let us cut down, but let him prepare first. That is in what we try to see that the tree grows full. Okay, whether it is complex, not complex, forget, let it grow. And then what we are trying to do, we are trying to remove the unnecessary things. That means in the tree, we are trying to remove the unnecessary branches and all, right? Same like what we are doing in the student's exam. So we are saying let us remove the unnecessary things now, and let us focus on improving the things for the exam. This is what is postponed. Okay. So this, very small thing, because, many students are there. I just wanted to tell this example. So this is how you can relate, pre-pruning to the post-pruning scenario. Now, let us go to the next question. So what is a random forest? Now, we are talking about the, great random forest algorithm. So what is random forest? Basically, you can tell random forest is a algorithm which is a combination. First of all, the very, very important point you have to tell is random forest is a algorithm which is an ensemble technique. So very important thing you should tell is it's an ensemble technique. Okay, so first you should tell that. Okay, so that it is a ensemble technique. Now, before the person asks you what's an ensemble technique, you should be telling that combination of multiple models is what an ensemble technique is. Sometimes one algorithm is not sufficient or one model is not sufficient. So we are mixing 2 models or 3 models or 4 models. So if you mix at least 2 models, then it becomes an ensemble technique, right? And here for random forest, what we mix 2 models. Okay, one is building decision trees. Okay, so multiple decision trees, and the other model is bagging. Okay, so you can tell like that and keep it simple. And you can tell that it is used for both classification and regression. That anyway you have to tell again, because even random forest is capable of that. Okay, so next is how does it work? So you can tell the most important thing is, the most important thing in random forest is the concept of bootstrap, or you can say bagging. So the word, you can say, if you don't remember the word bootstrap aggregation, because some people can remember, some cannot remember. So it is basically bootstrap, Bootstrap, strap, bootstrap aggregation. Okay, so if you don't remember what is bootstrap aggregation, you can just use the word bagging, bagging. So bagging, or if you say bagging or if you say bootstrap aggregation, both are same. Okay, so you can just tell bagging. Okay, so that will be necessary. So that is enough. Okay, so you can say that the concept is based on bagging. Now, if the person asks what is bagging, you can tell sampling with replacement. Just tell this. Okay, you tell sampling with replacement is what bagging is. Still the person asks you, please elaborate, then you can tell. Okay, so again, because I remember yesterday telling you about what is bagging, for more than 15-20 minutes. So why? Because I'm explaining to you, that's why I'm doing it. But in interview, you cannot take up one particular thing that many time, that many minutes of time, unless and until that particular person questions you on that particular thing, asks you to explain you more, right? Then you can explain it in detail. Then you tell with an example, whatever you want to tell, you tell. Okay, you can tell any example. You can just search in internet also. You'll get multiple examples how you can explain bagging, or you can take my example. Anything, it'll be fine. So then you tell what is bagging if he stresses you. Okay, or else you just tell bagging is basically sampling with replacement. Okay, then you start telling that the bagging technique is where the sample sizes are also exactly the same as the original data set. So you keep on explaining with different examples, and how do you get the entire structure you tell, or else just tell it is based on the concept of decision trees, but not one decision tree, but multiple decision trees. Along with that, it uses the concept of bagging. Okay, then bagging is nothing but you only tell already, right? You just tell bagging is nothing but the sampling with replacement. That's it. Just keep that. If they push, then you also push the concept and you tell more. Okay, fine. So next is the random selection, right? And one more important thing, what happens is it is basically voting, and it is the most successful thing in random forest is building multiple decision trees. Apart from that, doing this sampling with replacement, along with that, having a random feature selection, along with that, doing majority voting for predicting the outcome class, doing the majority voting for the outcome class. This is what is making the random forest a very important and a useful algorithm. I would say not important, important is also very small. Useful algorithm to make predictions or build a model in the real world, because we need algorithms which can help us in the real world to solve the problem in the real world, right? So that is what our focus should be. Okay, so next is the key features are basically using the ensemble nature, right, and handling high dimensional data. You don't worry about how many ever rows or features, how many records are there or rows are there, or how many features are there or columns are there. It doesn't matter. The only thing what matters is sometimes the training part takes little more time. Fine, we are not, in my opinion, never bother about the training time. It's okay. Bother about the accuracy and the result, how good it is giving you. That is the very important part. So after that, next thing is, it is capable of handling the missing values. It is very scalable. That things you can tell. So advantages are this is majorly reducing the problem of overfitting. So the problem of overfitting is not uh, you know is solved, I can say, mostly by using the random forest. So very good accuracy, very practical algorithm can be used in reality. Okay, so where you can predict, so you can put your hand on your heart and say, yes, my random forest works really well. Actually, decision tree itself is a very good algorithm. But because of that overfitting problem, we are always talking about the random forest. So that is the only thing. So disadvantages, you can tell that it can be for smaller data sets. I would not suggest random forest because the way it works is mostly suited for larger data sets. So I would say for smaller data sets, never use random forest. So that is one thing I can tell you. And time wise, it takes a lot of time. If you feel it is at a disadvantage, it is a disadvantage for you. For me, it is not a disadvantage because I would say give time to train, no issues. So next thing is some applications also you can think of. You can you can use it for multiple tasks. You can give many uh, things. So next question is, how does random forest handle overfitting compared to a decision tree? So I think this one already we have discussed. I think in 1 or 2 lines I'll tell and I'll go to the next question. So what can you tell us? To solve this problem only, we are using the concept of bagging. Correct, no? Bootstrap aggregation. So you can tell how it helps. Okay. How it helps and why it helps. You can discuss this. Okay. So if you can discuss this concept, it will be just good how uniquely random forest solve this problem. And you can tell about the random selection in the random forest. So basically, how does this live up to the random selection and all those things? And then we have the ensemble averaging as well. So how do you use this, average technique? For example, this averaging is basically used for regression. Correct? No, average is basically used for regression. For classification, we go with the majority voting. And one more thing is, we can use this is very important. We can use the hyperparameters to basically give you the depth. Okay, so to determine the depth of the tree. Okay, so you can stop the building of a tree by creating the correct hyperparameters or tuning the hyperparameters. So yeah, that's it. You can just tell that. Now let us go to the next question, or I can say the a little bit higher questions, intermediate level. So what is feature importance in a random forest? How is it calculated? So what is feature importance? So if if you have to talk about what is feature importance, you have to tell that what are features first. Okay. So what are features first? So basically features are nothing but the attributes or the columns in the, right? So features are nothing but the, independent variables and the dependent variable. So these are basically used for model building and all. Okay, so that you can tell. And for doing this, we are using the concepts, how to identify which feature is important and all. For that, we are saying or using the concepts of Gini index, okay, or Gini impurity or Gini index, anything we can say. And then we are using the concepts of entropy as well, correct? So we are using the entropy model or Gini index to identify. Okay, so that is one thing you can tell. And for regression models, we are using the root mean square error and mean square error and so on. Okay. So I think that should be that we can answer. That should be sufficient. Keep it very simple. Okay. So if you want to take up any example on any particular feature, you can take up. That you can do it. If you have done anyway doing certain projects, so you'll be able to identify that what can be given or what can be implemented, right? What is actually given, right? And which features are there, and maybe you can just analyze in your brain that a certain kind of project you have done in random forest, and you can just identify and you just focus on that particular example. So I've done a certain project like this. So in that, these are the parameters and these are the important features I've selected based on this criteria. So you can just elaborate. That also project don't take big ones. Just keep it very simple. Don't tell just jujube and dummy projects and all. Uh, but apart from that, just tell something where it links to some real life. So something we have done which you can link it to the real life and you can tell a certain example. So based on that, you can just give justify the answer to this question. So next is what is bagging and boosting and how does random forest use bagging? Right? So this question is basically it is like asking, right, why random forest is only using bagging. So why it is not using the boosting technique? That is what indirectly the question is. Okay, so the methods in implementing bagging and boosting is basically different. Okay, so both are ensemble techniques. That means which combine multiple models, and that's how the model is actually built. Okay, fine. But how does they work, or how do they work? So the first thing is the bagging. In the bagging part, bagging is already we have understood what is bagging, right? So basically bagging is nothing but the bootstrap aggregation. So we use the bootstrap methods. That means the sampling with replacement, where we select the same amount of samples as the original one. Okay, so then we build a model, then we go with the majority voting and all those things, average for the regression. So these and all you already know. So you can tell that what happens if you use backing and all. You can just give a specific example. And for boosting, so coming to the boosting part, so boosting is a method actually which is built on a sequential basis. Okay, so I'll keep it this question very simple. Anyway, I'll explain to you in detail about boosting. Okay, don't worry about that. So this basically actually helps a model to build in a sequential way. So that means in a one by one structured way. Okay, one step after the other, one step after the other, one step after the other. So if you do this in a sequential way, what happens is if you're doing any mistake or you have done any mistake in the previous one, that can be corrected in the next one. So it will keep on correcting the mistakes. So what happens is the bias gets reduced. So you can use it. You can use the boosting techniques when you feel there is more bias in the data set. So yeah, this one I thought to tell you when when I'm discussing the boosting part, but it's okay, fine. Situation has come. So I just wanted to tell. So when there is more bias in the data set, basically we go with the boosting methods, because basically this boosting, just remember a very important point. Boosting actually tries to reduce the bias in the data, and bagging tries to reduce the variance in the data. So yeah, so we have discussed now one question, variance and bias trade-off. That there we have spoken about overfitting, underfitting, and all those things. And this is directly related to that. So if you feel you need to reduce the variance in the data, you can use the bagging method. And if you feel that you have to reduce the bias in the data, so reducing the variance in the data is what bagging is. You'll be using the bagging methods. If you want to reduce the bias in the data, you can use the boosting methods, right? This is, you have to keep in mind, never forget this. So because it is based upon, error correction, right? At each model, the error doesn't go forward. The error has to or should not go forward according to the law of using a boosting method. Okay, and we just remember that for time being. Even more, uh, but there is a this point also I don't want to cover. Okay, fine, but a situation has there. Basically, if you don't tune properly, since it is more focused on bias, reducing the bias. If it is not tuned properly, the boosting methods are prone to overfitting problems, but bagging is not prone to overfitting. So there are some of the things which we have to even more discuss. That is why I discuss interview questions in very detail as well. So we have methods like gradient boost, ADA boosting. ADA boosting is nothing but adaptive boosting. Okay, so maybe you know adaptive boosting. So we call it as shortcut ADA boosting, and we have something called as XG boosting also, gradient boosting. So that we will already discuss. So all the gradient boosting methods comes under boosting methods. So if in detail, if they ask you, you can tell them how a random forest actually uses the um, backing. I think you already know how to answer this question. I've discussed a lot actually. I'm confident that we'll be able to answer the question. So now let us go to the next part. So what are the hyperparameters in a random forest and how do they impact on the model performance? So what are the hyperparameters? So here you can talk about the number of trees, which are nothing but the number of estimators. So usually we go with the simple. See, very simple to understand. More the number of trees you take, more the training time. Okay. So keeping in that mind, if you feel that okay, but I cannot wait for long time to train, so I'll take very small, less number of trees and I'll finish my job. No, that doesn't work properly, right? So if you are going with random forest, you need to have patience. So if you have patience, you have to go with the random forest because the training takes a lot of time because of the data, right? And the number of trees you have given. For example, if you have given some 100 trees, so you can imagine the training process will take a lot of time, correct? No, and based on that, the amount of training time, it obviously takes a lot of time to build and all those things. So yeah, so number of trees are more, so it takes a lot of time, but it is very important because it is a hyperparameter. So these are the things which control or basically these actually what they do is they try to improve the model performance. So we have to be very careful on things which are focused on improving the model's performance. So in that, one certain thing is the number of trees. So you cannot just for the sake of training time or that thinking that the training time will take a lot of time, never build very less trees, right? You want you want more people to vote. You think like this. So you think like a like an election campaign, right? So they want more people to vote and more favorable cases. So the same thing here, you are not thinking about the favorable cases because it will only take a majority voting and it will actually give you the voting. Okay, so you need not worry about that, but you want more people to vote. So here, if you take the election part in mind, it's the same thing here. What is happening? Basically the trees are voting, right? The trees are voting, right? So if you take 100 trees, if you get some 70 or 75 cases as yes, so that means the majority voting goes for yes. So the outcome will be a yes. That's what happens in random forest. So so more number of trees, it is good, right? So for example, 60% is better than, if you say 60 votes is good in 100 votes than, 6 votes in 10 votes. So, the number of trees increases, the confidence also increases with the, majority voting. So, and that's where we use the hyperparameters, number of trees, which is very important to, build the, or you can say to vote. So next thing is the depth. So in depth, you should be very careful in building the depth of the model because basically we are using the random forest so that the model doesn't overfit. So that criteria has to be satisfied. So that one you can keep it in mind before going into that. And the sample size should be decently large. Okay, that should be focused in mind. So minimum samples and maximum samples that we have already discussed. And obviously the bootstrap method, which is the bagging method, which can be used. Okay. And now the important thing is already we have spoken about this, the hyperparameters part. When it comes to the, in the, sorry, the, you can say bias variance trade-off. When it comes to the, as I already told you, so variance part, you have to use the bagging, and for the reducing the bias part, you have to use the boosting methods. So I think that should be enough to answer that question. I don't think it is not more than that. We have discussed so much. So what is out of bag error in random forest? So before this, I may take some questions because only once I've given you chance to answer, give me questions. So I'll just take a couple of minutes. Yeah. So you can just ask any questions, not answer. I'll answer them. So you can just give me some questions if you So you can give your attendance as well. So in the meanwhile, you have any questions, please you can post, and you can also give your attendance. So both things you can do. So we'll just take some couple of minutes. If you don't have anything, we'll go forward. If you have questions, please ask. I'll answer your questions. So till, yeah, third question we have done here, right? So out of that, we have to discuss. So role of bootstrap, I think we can quit that also. I think one or two questions which we already have discussed. So how to handle categorical, that also we have discussed actually. Yeah, we can quickly move with some questions actually. So just any questions? Fine. I think we can go ahead and get any questions. Fine. Okay. So let us continue. I think no questions, I guess. Okay. Fine. I've waited enough. Okay. So let us continue with the next one. What is out of bag error in random forest? Okay. So actually, we have discussed this concept. What is this out of bag also? And what actually happens in random forest is basically what the random forest actually does is it will actually segregate or it will segregate a particular amount of data for testing. Okay, so even yesterday's example also we have seen. So we take only a certain amount of data, and a certain amount of data is actually kept. Apart from our testing, we keep one more thing for again validation. So that is what this out of bag concept is. So we have a training data, validation data. Apart from that, this set or ring, again we save. I think some 92% we have taken, right? So we have left some 8% of the data, and in this 92% we have splitted the data into training and testing, and we try to train on this, and again we test on this splitting what we have done. Again we test with the unseen also. So that is how this out of bag works, and this out of bag algorithm is actually a very important thing, which actually helps you to have a very good I can say very good to make sure, right? Make sure 100% that our algorithm is working really well. Okay. So what are the advantages is for validation, it becomes very easy. So it is like, automatically you are only providing internal cross validation, and efficiency, it is more reliable. It is, the generalization part is taken care of. Okay, so this is what this OOB out of bag actually helps you. So next is, how does random forest handle missing data? So you need not worry about you can just, if somebody asks a question in the interview, we can say with a straightforward answer. First of all, is we need not worry about the missing values in the data set, because random forest itself is capable of basically handling the data, even though there is a missing data in the data set. So if there is a missing data in the data set also, the random forest is capable of handling. So that you in one point you can mention. And due to this method of bootstrap and all those things, it is actually training on a certain way so that the features are not missed out, and it actually builds, or I can say trains on the patterns, right? It identifies the trends and patterns in the data. So it is not a big problem for it if it has a missing data as well. Okay. And it also has this imputations. Okay. So you can actually, it also uses that imputations like the mean or median or k nearest neighbors. So it is capable of using these interpretations also. So we need not worry actually to when we are using a random forest about the missing values. Okay. So next is usually we use the imputation methods, right, to replace. But here it only takes care, the mechanism itself is like that. So it only takes care of the missing values. We need not worry at both, training and testing at stage. So next is, what is bootstrap? What is the role of bootstrap in random forest? Right. So yeah, I think we're on the sixth question, right? So what is the role of bootstrap in random forest? So this also we have actually discussed, correct? No, we have already spoken about bootstrap, what happens in bootstrap. So what happens, so you can tell an example, you can take an example and you can explain what happens in a bootstrap. I think already this is covered, and if still they're asking very detailedly, you can maybe cover. I don't think you can tell the key aspects of bootstrap basically is creating multiple training samples, right? This is one thing. Second thing is, you can you can tell the diversity in the ensemble methods. And the third point, you can tell this out of bag estimation method, which is helping for the bootstrap. And then because of this, it actually reduces the overfitting problem. So this also you can tell. And yeah, I think that should be sufficient. So next thing is, how does random forest prevent multicollinearity? So this multicollinearity is prevented by the random forest, right? Because since it is using the random splits, okay? So since it is using a random split, the problem of multicollinearity is automatically taken care of. So when you talk about multicollinearity, so multicollinearity is nothing but the correlation between the independent variables. So high multicollinearity is not good. Okay, so it basically aggregates your multiple decision trees. That is why what happens is it is actually robust to multicollinearity. So mostly the problem doesn't occur in random forest. Okay, and there are some key features. That's why this bagging concept is used. ensemble technique. So you can just justify on this. Already you would have told about this. Maybe if they are not asking any of those questions which are related to this, then they might ask you about this multicollinearity question. But if they're asking something already related to what we do in random forest and all, nobody is going to ask you again what is multicollinearity, because the correlation part is taken care of in the random forest part, because it is creating. That is why the bootstrap aggregation or the bagging technique is a very, very successful method, because it overcomes many, many, many problems, right? So that is why bagging and boosting are one successful methods in the machine learning department, right? So yeah, already a very good successful methods are there. So that is why we don't overcome the problem of multicollinearity. We need not break our head or worry about the missing data also. So like that, there are some luxuries are there when you are applying this bagging and boosting techniques. Okay. So bagging, always remember, if you want to reduce variance, you can use the bagging methods. So you should understand data first, and then you can apply the bagging or boosting. So for reduction of bias, you can use the boosting methods. So this one always keep in mind, never forget this. So next thing is, what are some of the use cases? Okay. So use cases, you know better already, because we have discussed many use cases, right? So for classification, you can say fraud detection, uh, customer segmentation, medical diagnosis. Medical diagnosis, one's good field. And for regression, you can say house price predictions, stock market price prediction. Then you can use the energy consumption. And for anomaly detections, we can say cyber security, right? And industry manufacturing, bioinformatics, right? And text classification, we can use the random forest. Okay, so there's a method called, TD-IDF, yeah, term frequency and inverse document frequency. For this, we use the random forest. Okay, so I'll tell you that when we go to NLP. Okay, so for that, for sentiment analysis and all, we use the random forest method also. So it is useful in many ways. Where it is not used, you tell me. Everywhere it can be used. So that is why it is a very important algorithm. And ability to handle the missing values. So able to classify in CNN models. In CNN models, we are going to use the random forest model, right? So yeah, what not or where not, right? Time series forecasting you can use, supply chain field. So there are too many applications, right? Where actually we can use the random forest. So now going to the next part, what is the main differences between random forest and gradient boosting algorithms? So basically this is about bagging and boosting only, because random forest is a bagging method and gradient boosting is a boosting method. So we already have spoken about, and I already told you boosting in detail, I will tell you. Okay. So boosting anyway in detail, I will tell you. But as far as time being, you can remember that this bagging method is based on this bootstrap aggregation. So that is one thing. And boosting is basically a sequential approach. Okay. We don't use this majority voting, averaging for regression. All these things are not used. These are the methods of bagging. For boosting, we don't do this. We only build sequential models. And at each model, we try to rectify the errors which are there in the previous model. That's it only we do. While implementing, you may understand a little more better rather than me just saying some theoretical things. So next, the way the learn is different from what happens. They're completely different methods like that. You can understand for the time being. So bias variance trade-off also, how random forest or the gradient boosting methods work is that is in where the when we see if we see higher variance on the data set, if we see higher variance in the data set, that means there is low bias. So if there is higher variance, you want to reduce the higher variance, you have to use the bagging methods. That is in where you know that there is low bias. So for boosting method, you know that the there is a higher bias and lower variance. So since the bias is higher, we want to reduce the bias. So there is a low variance in this. So we are going to use the boosting method. Okay. And modern complexity, basically both are not very complex. It is, based on, I wouldn't say it is very complex. It is based upon how do you tune and how do you use. As simple as that. So next is the speed and accuracy. So they are basically faster actually. To be fair, boosting algorithms are faster compared to bagging. Yeah, that is true. We should accept. So boosting is much more faster actually compared to bagging algorithms. So overfitting part, I can say bagging usually doesn't overfit actually. To be fair, like uh, I would say, or not, I've not seen really actually overfitting, so that doesn't happen. But the problem is with boosting actually overfits. So you have to be very careful. Boosting is a very one, I can say, boosting is a very successful algorithm. Okay, don't get me wrong. So it's a very successful algorithm, but the problem is there is a chance of overfitting, but the chance of overfitting is very less in the bagging. Okay, so this one we have to keep it in mind. So what to do, how to apply and all, I'll tell you. Okay, so because there's a concept called SHAP, SHAP. So that is used in boosting. So that I'll cover when we are doing the boosting algorithms. So use cases, you can tell any examples. Okay, so whatever you can apply for bagging and boosting. So next important thing is how does random forest handle categorical data? So how does the random forest use a categorical data? So that already you know, right? So how does it handle? So how does it handle? It does the process of, label encoding, right? Or you can say one-hot encoding, right? So you can use this method of label encoding or one-hot encoding. So for that, you can use where it will try to help you to speed up the process, okay, and to train more often than not, or very easy. So training process can be done so that you can tell based on some important aspects. So next is the advanced questions. I'll cover a few here, okay, maybe due to kind time constraints. Um, so you can just, anyway, I'll share the answers. You can just, go through some of the questions. So any doubts, you can just ask me as well. So here you can see bias and variance trade-off. We can skip this because seventh question you can see because that is already have been discussed. And how does this grid search and randomized search is basically for hyperparametric tuning. This is the sixth question. So common evaluation metrics for decision trees and random forest 5, 6, 7 we have already discussed, right? So the how does a Gini impurity or a entropy works, that also we have discussed actually. So that is also done, and impact of increasing the number of trees, that is also done. So role of random selection feature, that also we have done actually, to be fair. So almost in advanced questions in basic and intermediate we have covered. But why we are calling this as advanced basically is this is focused on one particular area and highlighting it, and they're expecting answers from it, right? So this Gini impurity and all, you can just explain that what is this Gini impurity, how does the formulas work, right? And it can answer your question. Okay. And then what is the impact of increasing the number of trees? Because sometimes the less trees are not sufficient. So we are going with increasing of the number of trees. Okay. And because of that, it will reduce the overfitting and all these problems that we have already discussed. Correct? No? So by this time you would have aware of. Again, I don't want to touch that. So role of feature selection random, because it is very important that how does this random forest help in random selection. That is what this bagging concept is basically about. So you can explain that if somebody asks you this question. So next, let me see. So we can discuss about this SHAP. Okay. So this SHAP question we can interpret or we can discuss. So here we can talk about this SHAP features or feature importance. So basically what happens when it comes to the feature importance particularly. So this tries to identify, okay, the most important features which are actually there in a particular prediction model. So which are very important and how does it work? And coming to the SHAP, actually SHAP is more focused. Actually, this is a boosting concept. So SHAP is nothing but Shapley additive explanations. Okay, it's a kind of a different name. So this is basically a concept which is contributing for a prediction. Okay, so what is this as? It is actually how to tell in a very simple way is basically it's a way to provide or interpret a particular feature on a given observation. So how a particular feature transforms, or how a particular feature changes for a particular record, what happens with a particular input. So that is what the SHAP is basically is. Anyway, we'll do this concept also. Okay, and if I go down, so trees, discussion of trees and all we have done. Maybe we can also discuss the, just give me a minute. So what are some common performance metrics? So metrics, you can say about the metrics such as, accuracy, precision, recall, F1 score, and all those things you can discuss, because those are the common metrics which are used. And apart from that, you can tell about the AUC, ROC curves, log loss, right? Log loss we can speak of. And then we can also talk about the regression methods, where the methods are used, like the mean square error, mean absolute error, root mean square error, R square. So all these things we can talk about. Even we have adjusted R square, which we have discussed, correct? No? Then you can just compare decision trees, random forest. So I think that should be fine. So next thing is, how do you tune a hyperparameter of a random forest using grid search? Okay, so basically what happens in a random forest is basically, the things happen that we already have seen. And the hyperparameters, what can be tuned is basically the number of estimators, or you can say minimum or maximum depth of the model. So this also we have discussed some criterias, correct now? And we can create a criteria. That is what this grid search and see. Simple. Say I'll make it very simple. Okay. Grid search is basically used to define the values for a hyperparameters. So this is what I'm expecting from each hyperparameter, this much depth. So that is what a grid search is basically. But what is a randomized search? Randomized search is nothing. It's very similar to grid, but there's a small difference. This is more focused on so we are saying random, no? So that is why it is more focused on sampling methods, or sampling for the data. So that is what this randomized search is basically about. And anyway, we follow the cross validations and all that we already follow. So next is explain the bias and variance trade-off. So this also we have actually discussed. So this is where the how to use, when to use bagging, when to use boosting and all. So this is basically this decision trees and random forest are used. These are both basically focused on reducing the bias, right? The boosting is most focused on reducing the variance. Okay. So next, what we can think of, what is the next one? What is a tree? What is a forest of extremely randomized trees and extra tree classifiers, and how does it suffer? Sorry, how does it? Sorry, how does it differ from random forest? So for this question, there is something. There is concept of when we talk about this concept, there is, when we discuss, we have something called as an extra trees. So this extra trace classifier is basically very simple to that of the the concept of random forest only. But here this extra trees, what happens is we create even more trees, and this is actually a method which is actually based upon random forest only. Here we are choosing extra trees which will lesser the randomness. Okay, so I wouldn't suggest much of this method because uh, um, randomness is sometimes creating overfitting, but the problem is randomness also doesn't create, and it also leads to giving more, good outcome also. So in that way, we can think that randomness is good sometimes, sometimes not good. But uh, extra trees also actually helps in reducing the more variance part also. So in that, I can say extra trees will be good. But both are fine, okay, by using extra trees classifier or by using only random forest. Both are good, but in certain scenarios, extra trees classifier, I would actually say it is better actually, particularly in using the for using in the larger data sets. And one more important thing I found in my experience of using extra trees is extra trees are a little more faster compared to the random forest classifier. So that is one thing you can that you can actually think of. Okay. So next is how does a random forest deal with an imbalanced data sets? So how does it deal is basically, the most important thing what we have to do is in random forest, we have to, uh, make sure that, uh, I can say somewhat like missing values. So like missing values, random forest is also capable of handling this imbalance on the data set. But, at a certain extent, we also have to be careful while implementing the random forest part because we don't need it to go towards the majority class. That's what biasness comes into the data. So we have to be careful while we are dealing with an imbalanced data sets. Okay, so to improve one such method which comes to mind always is this SMOT method, synthetic sampling methods. So yeah, so SMOT method if you use, I don't see this as the biggest problem because anyway I use SMOT when I'm dealing with random forest. I go with a SMOT, creating synthetic samples for the minority class. So if we do this, automatically the problem of the problem of what I'm saying, the what we are talking about is the imbalance part that is automatically taken care of. So we need not worry too much about this problem. I would not worry because I usually implement the SMOT technique obviously into the my random forest model. So that is why I am very much confident that I'm not bothered about this imbalance, data imbalance problem when it comes to the random forest. So I'm not worried about this. You also need not worry about that problem. Okay, to be fair. So let us discuss the scalability and computational challenges of random forest for larger data sets. So the same thing, the scalability, the training part, and the time, the time it takes, and the amount of training it does. Uh, yeah, and the amount of time it takes and amount of memory it uses and the amount of more processing power it is required. So that is, apart from that, I don't see any problem. So if you have any good processing power, or you're able to spend some time, I don't see random forest as a problem. I never saw random forest as a problem. So that is why I'm very confident in I'm saying that random forest is a very good algorithm. So I think that should be fine. Almost, it's also time almost up. So if you have any questions, maybe if you're not able to answer now, ask now, you can also ask it for tomorrow's session. You can keep it for tomorrow's session also. Um, Ma'am, shall we wait for questions or shall we end it? And It's 9 exactly.
Yeah, Shashank. We'll close this.
Sure. So definitely, if you have any questions, maybe you can, keep in mind, and you can ask me tomorrow also. You can make a note.
Yeah, thank you. Students, I'm sharing the attendance link. Please mark your attendance if you missed out. And any more questions, you can ask me. And tomorrow and day after tomorrow, we don't have a session. Okay, again, we have session on Monday. Okay. Okay, I hope no more questions. So good to go. We'll wind up the session and